All right. Good afternoon, educators. Hi, Blaze. Hi, David. How's everything going? It's
Hello.
been a while. Oh, I'm so excited for all of us to be back. School's officially back in session. I know y'all are happy about that. All right. Awesome. Okay. Well, as educators are coming in, thank you all for joining us for this year's Engineering and Advanced Manufacturing Advisory Board. Please be sure to mute yourself upon entry. I know some of us might still be in our classes or finishing up some meetings, so no worries at all. Okay. And for check-in purposes, please find the chat. The icon's located at the bottom of your screen. We ask that you type your first and last name, job title, and name of school or district that you work with. And then in your actual Zoom frame, please make sure that you have your first and last name. This will help with any other teachers would like to network with you or message privately. We will have the chat open. We do also have a few industry representatives that will be joining us to participate not only on the industry panel, but as well if you all have any questions about the opportunities that they have available for your students. Okay, and again, for those of us that have just joined in, please be sure to check in the chat box. You'll list your first and last name, your job title, and the name of your school. Also, please be sure to mute yourself. We want to make sure that the backgrounds are not echoing. And once we start our panel sessions, we do ask if you're not on the panel, please be sure to turn your camera off. This will help us highlight the speakers. For those of you who have not met, I actually do want to make sure that I introduce our VitaLink president, Ms. April Barnes.
Put me on the spot, Ari. Hi, everybody.
Hi.
Welcome back. It's great to see you all. And I'm excited for our first advisory board for the year and so grateful for the panelists that are gracing us with their presence today and telling us all about their business and how we can get more students involved. So thank you all for coming and spending your Friday afternoon with us, and I hope you all enjoy it, and we'll see you again soon.
Thank you, Ms. April. So as we're getting started, I do want to highlight some updates and some changes that we've had over the summer, as well as some events that we have coming up. First and foremost, if you haven't noticed already, VitaLink has a new logo and new colors. So within our partnership, we actually did a relaunch back in April of this year. So if you missed the party, sorry, but we do have pictures that we can send to you. Along with the updates, make sure. Yes, okay. Along with the updates, we've launched our new official website where you will see, again, new colors, preparing for new updated events. You can click this button and it'll take you directly to our events that we have coming up this month and next month. You'll also see some events that we had over the summer on local college campuses for your high school students. And then for my favorite tab, of course, is our program. Your educators can check out what we have available for your students as it pertains to academies, exhibit days, competitions. And we haven't forgot about you all. We do have educator programs for advisory boards. If you are specifically looking for an educator tour, which was previously known as the Professional Learning Community, you can email Netta or Ms. April directly for any questions on how to set that up with us. All right. Okay. And then if you have not received it, I'll make sure that you receive the agenda packet Today, we do have a great group of college representatives. They're going to share about what they have available on their college campuses. We'll also take a quick break and then dive right into the industry panel to hear from some representatives about what your students can work towards and what skills that they can build. And then we have a quick evaluation just to receive feedback from you all on how you felt about today's advisory board. You'll also receive in your packet the remaining dates that we have for the next advisory boards throughout the school year. So any admin on the call, feel free to share this with the educators in your district. For industry representatives, we do have additional opportunities on how you can have a free exhibit booth, virtual and in person, at any of our exhibit days, college and career fairs, as well as our huge Student Leadership Summit, which if you haven't heard, we're holding a Student Leadership Summit on a Wednesday, November 30th. It will be in person at the Delta Hotel, only $20 per student. There will be, I believe, 9 workshops available, all hands-on, skills building, and leadership focused, as well as 2 panel sessions and a roundtable session where students can meet with the mentors, interview them, and ask them directly how can they be in their shoes. Okay. Let's go over here. Share. Okay. All right. And then next, we are going to call our college panel to the screen. If you're not on the college panel, please turn your camera off and please make sure you're muted. This does help us highlight the representatives as they're sharing about their college programs that are available for your students. If we do have George, Dan, Angelo, David, Glenn, and Michael on the call, if you could please turn your cameras on. And then we do have our facilitator, Ms. Morgan Zandinella of Medtronic. Morgan, we might be waiting for a few more. I do see Dan, Michael, and Angelo. Let me see. Let's see, I see Dan is here. And David's here and Angelo. Okay. All right. So I'm going to go ahead and pass it off to Morgan. That way we can go ahead and get started. Thank you all so much.
Hey, thank you, Ari, and thanks everyone for joining the Industry Advisory Board today, and starting off with our college panel today. So as Ari mentioned, hi, I'm Morgan Zandinella. I'm currently an engineering program manager at Medtronic, our neurovascular division in Irvine, and I'm also serving as the president of Society of Women Engineers of Orange County, and your moderator for today. So I'd like to start off with getting introductions from each of our panelists today. So looking at the Hollywood squares on the screen here, David, do you want to go first?
Hello, I'm David Giordano. I teach engineering and advanced manufacturing at Saddleback College.
Thanks, David. And Michael?
Hello, I'm Michael Buchler. I teach manufacturing technology at Santa Ana College.
Awesome, welcome. And Angelo?
Hi, I'm Angelo. I teach engineering at Orange Coast College.
Awesome. Thank you so much for joining us. And any other panelists that I missed? Oh, Glenn?
Hi, I'm Glenn Stevenson. I'm the department chair for advanced manufacturing at Saddleback College. I also teach all the advanced CAD.
Saddleback.
Thanks so much for joining us. Any other panelists on the call? I think that's it. All right, okay. Well, let's kind of dive in to some of the questions that we have prepared. But I do want to also remind everyone that the chat is being moderated. So if you have any questions as we're going through, please drop them in the chat and we'll make sure to cover those as well. So to start us off, maybe we'll go in the same order, and we'll start with you, David. I kind of wanted to hear, a little bit more about dual enrollment and how that's improving high school students' knowledge and skills before entering your courses, if that's something you've experienced.
Well, in terms of dual enrollment, they can earn college credit, so it gives them a head start and a early jump into taking their college course. It also gives them a little knowledge about what to expect when they take college courses. So I think those are a couple of the benefits of students doing a dual enrollment course at their school.
Yeah, get a little bit of a feel for the college environment for sure, and a little bit at a time too, rather than all at once. Makes sense. Michael, do you have anything to add?
No, I think for a lot of the high schools now, it's kind of a little bit new. I think the dual enrollment was frowned upon before. The high school students wanted to have their students and the college students wanted to have their students. So we haven't seen a real impact within the class, but I'm excited for it. If not for within our department, at least the students coming in have a little more confidence in their first semester full-time, let's say coming full-time if they have just even one class under their belt. I think that will add confidence to the students and increase completion rates. I'm excited about it.
Yeah, that's awesome. Angela, what do you think? Have you experienced dual enrollment and how that's improving high school students coming through your classes?
So I haven't in the engineering discipline, but I have in other disciplines, and I have to say that that's a great way for students to really get their feet wet when it comes to going to college. Students that just go from high school to college, no matter how much they've tried to prepare, they're usually unprepared to really experience their college life and be successful with all that independence and all those degrees of freedom. Whereas when they do dual enrollment, especially if it's done on the college campus, they actually get to see what it really means to go to college, so that they start to adapt to that different mindset, and that usually also translates in just better outcomes and better success rates.
Yeah, I can see that. Just like Michael was saying too, it's the confidence building too that comes with it. I love it. Yeah. What about you, Glenn?
Well, I agree with what was said. But I do, Michael, see a lot more of the students doing dual enrollment than I have in the past.
Okay, so we're building momentum there. That's exciting. And then I think we just had another panelist join us. Hi, Dan. Do you want to do a brief introduction? Your name, your title and college, and a brief summary of your department or courses? Yeah.
Sure. My name's Dan O'Brien. I'm with Fullerton College. I teach in the machine technology department. I'm the department coordinator. So we got a full machine shop program here, along with manual CNC. We also have metrology. So it's a complete community college program for manufacturing skills.
Awesome. And I'm not sure if you heard me ask the question originally, but if there's anything you wanted to add around your experience having high school students with dual enrollment and how that might be impacting their knowledge and skills before entering your courses.
We've had a couple of students do dual enrollment with some of our local high schools, La Habra, a couple with Esperanza. And some have worked out quite well. Sometimes it's hard to, we had one this semester that unfortunately never panned out because they couldn't, our class was too long in the afternoon, and the high school district didn't care for the hours. So anyway, so that one didn't happen. But we've had a few in the past that have really had students that basically had almost finished our CNC operator certificate before they even graduated high school. And I had one kid in particular that was getting a very good job offer before he even left high school. And so he ended up going on, I think he finished Cal Poly Pomona in manufacturing engineering now. So he had his path picked out. But it's been really good for the students that have taken advantage of it. Unfortunately, not a whole lot of them do that.
Yeah, I imagine that can be tough, especially like you were saying with timing and things like that.
Mm-hmm.
Yeah. All right. So kind of talking about that transition from, you know, from classes and connecting that with industry or as the real world experience. What could you say is like that real world experience? Do classes that that you offer students, how will that benefit them in entry level careers? And I'm going to kind of mix it up this time and go with Angelo first.
Thank you, Morgan. I always emphasize, and all the other instructors in engineering emphasized how important it is for engineering students to look outside of engineering classes, meaning that coursework alone might not be enough, and usually is not. So although we really try to teach them skills that are applicable, that are employable, engineering students need more than that. And I always recommend them to take courses where they have to also do hands-on. So fortunately for us at Orange Coast College, we have very strong technology division where we have all different technologies ranging from welding to manufacturing, advanced manufacturing. We have construction, woodworking, and so on and so forth. So they really have a possibility to take some of that engineering knowledge and see how it's applied by actually building things and making things, and how does it really put it into work. And that's something a lot of engineering students do. So they go ahead and get their welding certificates, their CNC certificates, and so on and so forth. And I think that really makes for much stronger professional figures for the future. And a lot of them do. So I see some students that graduate from us, then they transfer, and because they've done that path, they actually land really interesting jobs that they're very satisfied with. So it's something that I think all of us should encourage as much as possible.
Definitely, as someone who has worked with a lot of entry-level career or engineers early in their career, and even as myself, right, having that hands-on of knowing that it may look great in CAD, but how to actually build it makes a huge difference. Some of that practical knowledge, for sure. Does anyone else have anything to add to that?
Sure, I'd love to give some examples of the real world experience. Saddleback College, we have really worked hard to work with local industry and showing them and working with them on how they can use this advanced manufacturing or additive manufacturing to help them. So, I mean, I currently just had a company local that face and head and neck surgery, and they have a light source, and they just needed an adapter for a piece of equipment that's no longer made. And so they came in and I assigned that to the students, and they have come up with a new design and a way of producing them an adapter so they can keep using their age-old equipment. On the engineering and collaborative with other parts of campus, we are one of the only colleges that participates in the Mars Rover Challenge contest, and we have students from engineering, from math, from science, from manufacturing that are all working together to solve a real world problem with that Mars Rover Challenge.
That sounds awesome. I love that it sounds very interdisciplinary too.
Yes.
Very realistic. Yeah, definitely. And I think, David, maybe you had something you wanted to add?
Yeah, I was going to also add about, at Saddleback we have CNC equipment, so they could actually use real world equipment. They use real world software, SolidWorks, AutoCAD, Revit, you name it. So they get experience doing that. And I know in all my classes, I always have them work on a project and do presentation and communication skills, because that's definitely important in industry. And that can definitely separate good candidate from a great one.
Yes. 100%. Yes. The presentation and communication is vital, especially working in teams, for sure. Being able to present. Michael?
Yeah, within our program, our most issued certificate is a CNC programmer, CNC operator. So it's important for us within our courses that there's as much lab time on the physical machine as possible as a CNC operator, as a CNC programmer. And then the other thing we have within our program is we have 3 different types of control. So we'll have a Haas control, a Fanuc control, and a Siemens control. And there's other controls out there, but once the student leaves our program, if they go and the shop has an Akuma or some other type of control, they're not too intimidated that, oh no, haven't worked on this machine. They're confident enough to know that they could probably figure it out with a little bit of training based on the coursework they've completed with us.
Oh, yeah, I could see that for sure. I feel that way about CAD programs too, right? It's like the fundamental of how you do it, and then you can build on that and learn whichever software or controller happens to be in play. Yeah. All right, anyone else? Do we want to jump to the next question? All right. Okay, so this one's a two-parter. So I'll repeat it a couple of times. We may miss it as we get into our discussion here. But the first part of it is, can students receive a certificate or badge after completing your courses? And it sounds like from a few folks, the way they've answered, that's a yes. And then the second part to that question is, how many hours or credits must be completed in order to receive certifications? So I don't know, Dan, if you want to kick it off on this one.
Sure. Our machine technology department, we have 9 different certificates that we offer, everything from basic machinist level 1. We have CNC operator, a CNC machinist, which includes programming. We have individual smaller certificates that may include 2 classes in MasterCam or SurfCam or Fusion. We have metrology. We have 2 different metrology certificates. One is 13 units, the other one is 29 units. And then we also offer a certificate in a CNC Swiss setup, operation, and programming. Our certificates range anywhere from 128 hours for our more basic certificates. And then they go all the way up to, let's see, I got one for 496 hours. I got the full AS in manufacturing, which we offer as well, is almost 1,800 hours. So just a very wide variety depending upon what the students want to do. All of our certificates are stackable, so once they start entering into the program, the credits they earn for one of our more basic certificates, it applies towards pretty much the majority of the other more lengthy certificates.
Oh, that's awesome. Very cool. Angelo, do you wanna chime in for your program?
Yes, so for engineering, we don't have certificate options that we offer directly, but some of our courses lead straight into them. And specifically for CAD, we teach AutoCAD and SolidWorks, and students that complete the course where those 2 software packages are presented, they can actually get to a proficiency level where they're ready to do an exam and pass it. They have to be outside because we don't offer it in situ, but they can actually do that, and some students go ahead and do that. It's mostly them basically paying to get their certification, but they don't really have to add much more to the knowledge that they need to pass it. And the same goes for programming. So we have a programming in MATLAB course where they get to a point where they can actually earn up to 2 certificates, again, not through us because we don't offer them, but if they go to a third party that offers those type of certifications, then they can actually pursue them. And then when it comes to technology, I mean, I don't teach technology, but it's a similar scenario to what Dan said. So there's a possibility to get different level of certification in all the different fields of technology that we offer. And again, talking about engineering students, some of the most common ones are definitely welding and manufacturing. I would say that most students go into that, parallel with engineering.
Okay, definitely. Glenn, how about your program?
So similar to what last gentleman, Angelo, we have certificates for the programs that we teach. We also have industry certificates that the students can take after that program. So like, SolidWorks certification, or maybe even the Stratasys additive manufacturing certification, things like that. So the way we present our courses, there's enough hours, enough training in that the students can then go take those exams and those certifications.
Okay, awesome. And Michael, is it similar at Santa Ana as well?
Yeah, it is similar. It's of course we all go through program review every 4 years, so we look to examine and make sure our program is current with the needs of the student body and the industry. But our program currently we have a 12-unit SolidWorks certificate, which is 4 classes. So beginning, intermediate, advanced, and then a drawings class. So that is actually our smallest certificate. The next smallest certificate is 32 units, I think. And so it's basically any of our certificates most of them are CNC operator, CNC setup, CNC programmer are 32 units or more. And that generally can be coupled with general ed and you can be awarded an AS degree. Most of our students do go for the CNC setup operator or CNC programmer certificate. So it's set up in a way, our program's set up in a way the students have to complete and they're proficient entry level as opposed to just picking and choosing and taking a smaller section of courses for like a 12 or 20 unit certificate. We're not set up for the smaller certificates at this time.
Okay. All right. And last but certainly not least, David, do you want to chime in?
Oh, well, I'm at the same college as Glenn, so our program is already talked about there.
Perfect. We got it then.
Yep.
So Ari just messaged me. We have 10 minutes left. So I want to remind all of those attending that if you have any questions, definitely drop them in the chat. But in the time that we have remaining, I'm going to jump to the last question here that we have prepared, which is, what advice do you have for high school educators who are preparing students for engineering and manufacturing careers? And David, let's start with you this time.
I'd say 3 things that students could really benefit from: developing their problem-solving skills, teamwork, collaboration, as well as I mentioned before, communication, ability to communicate. Developing all those 3 skills will help them not only in their engineering courses, but their other general ed courses as well.
Yeah, definitely. How about you, Michael? Any advice that you'd have for our high school educators?
I would repeat what David had said and just, we're laid out in a way in education that we build upon the previous coursework. So in high school that they are good at, reading, writing, and arithmetic, basically to prepare them for college. So some students come prepared, some students are not in regards to their writing, their English skills, their comprehension skills, their critical thinking skills. So I think, again, just making sure the students are up to speed with that will make them successful in any program they do, certainly within our program.
Yeah, having a really strong foundation. Yeah. Glenn, any to add?
Well, I agree with Michael. It's just, that foundation is huge.
For sure. Dan or Angelo, any additional advice you might have?
I would definitely say the critical thinking skills are very important. Then one of the things that we like to do in college here with our projects is we typically will have a capstone project in a lot of our courses where the students have to make a multitude of components and parts that all assemble and fit together. And then that's where they really learn, about tolerances. If they don't make the parts out of tolerance, well, their little engine they're making or whatever it is they're making, it's not going to fit. And they're going to see it right away. And then they also can see, there's parts and components we can fabricate and manufacture. There's parts and components that really are better off buying, little pins and screws and things like that. They can kind of see how to acquire things and what it takes to put a whole product together, maybe in a real basic form, but obviously they get to the college level, you start getting a little more advanced in that area. But try to, present them with problems that they have to solve, because in the real world, it's all about solving problems. Like we have constant problems on our CNC machines, and you have to figure out creative ways, think outside the box to solve your problems many times. So anyway.
Yeah, I'd agree with that. I can see what you're saying, like more open-ended type critical thinking problems. Yeah. Angelo, any advice that you would have?
Yes, obviously everything everybody else has said, very important. So that first, and then on top of that, I would like to say that we do get very good engineering technology students from the school district or districts that we're in touch with, especially the Newport Mesa Unified School District. We get a lot of very good students, which means that the teachers are doing a great job at preparing those students for college and for what they're going to face. But if I were to say on a more general level, one of the things we see that students sometimes lack is, even if sometimes they do have good problem-solving skills, they might lack a little bit of that connection with the science aspect of them. And what I mean by that is sometimes students just struggle, for instance, with trigonometry, which is a very important aspect. And I'm not talking about, how to say, just getting into the heavy math part of it, but even just understanding how trigonometry applies to a lot of the problems that they solve in engineering technology. That's very important. Or, you know, things of this sort. Also physics, sometimes it's surprising how students don't realize how they're actually using some basic principles of physics to solve problems, and they don't quite make that connection. So it's important to emphasize that. It's important that they see also, how is a little bit more of the science that's behind maybe some of the projects, some of the things that they do, so that they can just build a stronger backbone and kind of grow from that without, how to say, necessarily having maybe some gaps or some doubts about, you know, how does this happen? It's sort of magic, you know. Some students have a little bit of that approach, whereas it's good to have that knowledge, that awareness of how they're actually applying knowledge, that, and they can also develop it themselves.
Oh, definitely. I think that's really striking a chord with me, Angela, is that the application part of it, right? And being able to translate that, and so connected, right? It seems like a lot of advice on the critical thinking and application. Well, awesome. Well, we have a couple of minutes left, so I do want to remind everyone, if you have a question, to drop it in the chat. But I actually have one. Hearing about your programs and the different certificates that are offered, if a teacher were to coach a student on which which certificate, right? And there's different levels of certificates. Do you have any advice, or is there coaching available or guidance around how to select those programs? And I don't know if anyone in particular wants to answer. I immediately triggered it when Dan started talking about it.
I'm sorry, can you repeat the question?
Yeah. So a lot of you mentioned having multiple levels of certification, and I'm just curious, like, as a student, how do they go about choosing which certificate program? Is that something that they would be coached or guided through, or is it really just up for them to kind of figure out?
Yeah, so we ran into this quite a bit. We've got, in some ways, we have two different students come to us. Some of them are a little interested in manufacturing. They have an idea and they want to get their feet wet, and maybe they're engineering students. They think they're going to transfer, or so they would come to us and kind of ask us questions. And then we have students who know I work in a shop and they know they're going to they want to become a Mastercam programmer because they know there's good money there. So usually either way, I would always suggest for students to go speak to the faculty in that department. We do have, and I think most campuses here have designated CTE counselors that are familiar with our programs, but even those counselors are not as familiar with our programs as the faculty are. The CTE counselors may be more familiar with other campus services, other student services like financial aid and such, but they're not really familiar with, certainly with the local industry and what classes should be taken the first semester. There's also the aspect of when the students enter a program and they might have stuff going outside, obviously a life outside of campus. So they might have a full-time job or a part-time job and family obligations. So it usually takes at least 1 to 2 semesters before the student can determine what class load they can take and really what they can shape their academic goals based on their other obligations. And I think faculty can help that out as well, because we know, hey, this is a hard class, or this is an easy class with no homework, and maybe you can couple out one hard and one easy class. You don't want to get three difficult classes and then have to drop one or two, and then that might slow you down from completing. So faculty is the answer to go see that faculty.
Thank you so much for that, Michael. And I think we're on just out of time now, but I want to thank you all so much for joining our panel today and providing your insights to all of our attendees here on the call. So thank you very much.
Thank you, Morgan.
Okay, thank you, Morgan, and thank you, college representatives, for sharing about your programs. For high school educators and representatives, I did want to highlight, if you haven't heard, we still have space available. BioLink is officially kicking off Manufacturing Month back in person. The flyer is attached as well in the agenda packet that I placed in the chat. If you have not received it, I'll attach it again shortly. But I do want to be sure that your educators are registering your students. Teachers, please make sure you confirm with your administrator, so that way I do not get yelled at, but I want to make sure you all sign up. I'll be honest, the industry tours are completely booked. However, we still have space available for the Fullerton College tour, as well as the Santa Ana College tour. We will now take a brief 10-minute break. Do not log off, but feel free to mute yourself or unmute if you want to network and talk to anyone on here, that's fine. Thank you all again so much. We'll come back at 4:11 to kick off with the industry panel. Thank you. Okay. All right, educators, welcome back. Feel free to keep your camera off and remain muted. We are officially going to start the industry panel. Where you have a great group of representatives here with us that have a wealth of knowledge to share about what your students can do, the skills they can build, and what they can do to work towards these specific career fields. I'm now going to turn it over to Ms. Morgan Zandanella, who is also moderating the industry panel. Thank you.
Thanks, Ari, and welcome industry panelists. I want to start off with some introductions. So if you could give me your name, your title, your company, and maybe a brief summary about what your company does. Stacy, would you like to kick us off?
Sure. Hi, my name is Stacy Darling. I'm an R&D Director of Compliance at Biosense Webster within Johnson & Johnson. So I've worked for J&J for 17 and a half years across many different companies within our MedTech group. And here in Orange County, we have the Biosense Webster team, Surgical Vision, Acclarent, a little bit of Mentor, as well as the Sarah Novus, all located at our Orange County campus.
Awesome. Got a MedTech heavy panel today then, because Sydney, do you want to introduce yourself?
Yeah, so I actually recently graduated from Cal Poly in San Luis Obispo with a bachelor's degree in biomedical engineering, and I've been an R&D 1 at Medtronic for about 4 months now. So Medtronic has a ton of locations, over 70 different disease states we treat, but I work at the neurovascular site where we make devices to treat stroke.
Awesome. And Juan?
Yes, good afternoon, everybody. My name is Juan Carreras. I have worked for the Boeing Company for a long time, 33 years. I am an engineer, and I personally work as a supplier program manager. Boeing has a lot of divisions, but primarily it's Boeing Commercial and Boeing Defense. I work for the defense part as part of the satellites in El Segundo, California.
Oh, very cool. Awesome. All right, so we're going to jump right into the questions. And again, just want to remind everyone that the chat is being moderated. So if you do have any questions as we talk to our panelists, feel free to drop it in there. And I think, yeah, okay. All right, and then we'll make sure to cover those ones as well. But while you're thinking about that, I'm going to kick us off with our first question, and it's a two-parter. So the first part is, does your company offer internships, apprenticeships, job shadowing, or other types of opportunities for students to gain experience? And then if yes, are there any certain requirements, specifically age or any others? And Juan, maybe you'd like to go first?
Certainly. Unfortunately, the Boeing company doesn't have many internships for high school students. Most of the internships that we offer in the engineering field, we get junior and senior engineering students to come in for the summer, and then they perform their work during the summer, junior and senior years, and usually if they like what they do, they stay with us. Most of them do. I am a mentor for High School Inc., Santa Ana Valley High, and I try to help engineering students as much as I can getting prepared for college, and we can talk about that some more later.
Yeah, awesome. Oh, that's great, Juan. Yeah, we should definitely touch on that more. Stacy?
Yeah, so we have our formal internship program, just like Juan, for engineering students, typically targeted for juniors and seniors. Every once in a while we do get a freshman or a sophomore in there. We don't have any formal programs for high school. And then we actually, from there, upon graduation, we have typically we have people enter into our leadership development rotation programs. So that's what we do from that perspective. We connect with high schools as well as kind of earlier in college through, I would say, the tours and We STEM 2D workshops and engagement and personal development. So we've done tours and bringing students on site, but it's not a formal program or apprenticeship or anything like that, for just helping to expose them.
Yeah, definitely. Yeah, I can say similar for Medtronic in that sense. But Sydney, why don't you describe your experience and what you know about at Medtronic?
Yeah, so we have a formal internship program as well for college students who are sophomores and above. And I actually was a part of that myself, and then was converted full-time, which we have about a 70% conversion rate. So really good future with Medtronic there. And I know we do have high school internships as well, but they're typically geared more towards underrepresented communities. So I did not get a chance to participate in one myself, but I know other people have, and there's more info on that on the early careers experience page.
Yeah, definitely. And I've had the privilege of, Sydney, of those exact programs you've talked about. We had over the summer with Girls Inc. And United Way to bring students on site for a longer term kind of experience, which is a great opportunity. Awesome. All right. Well, thank you all for sharing. So I'm going to kind of jump a little bit ahead here. And I want to talk about soft skills, which can also be just as important, even in the college panel, right? They're already talking about communication and some of the vital things that students need to have for the college level. But I'm curious, for entry-level employees, what would you say are the 3 top soft skills that they need to build before they're hired, and why are they so important? And maybe Stacy, you'd like to kick this one off for us.
Yeah, sure. So I will say I'm focused a lot of the conversation probably from this on the engineering side. We actually do have technician roles and machinists and a machine shop on site. So I do know a lot of the college representation. There's a lot of programs and things to support that. But so those would really be focused, I think, a lot more on the technical skills. But from the soft skill sides, specifically for our engineering roles in R&D or supply chain or manufacturing, I would say, one of the #1 things is engineers go into engineering because they like the math and science and the technical, but the importance of verbal and written communication, as an engineer is really critical to be successful with getting your ideas across and being able to document and defend them from a quality system perspective. The second one I would say, right, is that whole analytical, critical thinking, solving, being able to think through, you know, early in your career in high school and as you're starting engineering, a lot of times you go through and the problems you're working on have a specific answer the professor is looking for until you get into those capstone projects and some of those later ideas. So being able to start demonstrating that critical thinking. And then the last one, right, is being able to show that you have ownership of things and how you can lead as well as work on a team at any level, I think can be critical. So those are the 3 soft skills, you know, that come to mind for me right away.
Yeah, definitely. Sydney, do you have any that you would add?
Yeah, so I agree with the communication skills, both in terms of like public speaking. I think it's really important to get comfortable with that, whether you're doing like a formal presentation to leadership or just maybe a weekly team meeting. You can be the best engineer in the world, but if you can't synthesize this information and communicate it to people in an effective way, then you're not gonna be able to actually enact your ideas. So that's really important. And then I think communicating during conflict is equally important. So in any work environment, you're going to come across a situation where you have a different idea, or maybe you're working with someone from a function who has different priorities, and you need to be able to convey like the importance of your goals and your opinions in a respectful manner. And then kind of similar to what Stacy said, but having like ownership of things, having an independent personal drive, because I know as someone who recently came from college, there you're having deadlines, your professors are telling you when to turn things in, it's very scheduled. But now that I'm in the actual workforce, I have a ton of different projects and I kind of get to decide when they're done myself. So being able to prioritize and then plan out your time and actually follow that is really important.
Yeah, definitely. I love that. And Juan, and any others that you would add to the list we're accumulating here? Oh, I think you might still be on mute.
I was talking to mute, sorry.
No
these
worries.
These two ladies have said most of it, but I would add too that, you know, young people nowadays have such a tremendous skill level, you know, for multitasking and doing things quickly. But one of the things that it's important when you start working for a large company is the ability to work as a team member. And building a team and completing a project is one of the most important things that a project manager can do. And the young engineer needs to learn, if he doesn't already learn that in college, to work as a team to get the projects done, and understand that things take time to get done. You know, a lot of young engineers get frustrated after a year or two because things are not happening fast enough for them. So hopefully companies will develop methods to keep young engineers at one company for more than 2 or 3 or 4 years, you know, before they jump into the next one. So that's what I have to contribute. Communications and writing skills and math and physics, all of that is really important. When you get to do your job, it's really paying attention to detail and just getting the work done.
Yeah, definitely. Yeah, I can relate to that. Medical device for sure. The product development cycle is a lot longer than what I had originally conceptualized. So I can relate to that advice, Juan. So thank you. All right, so we talked a little bit about soft skills, but I'm curious if there's any top technical skills that you would suggest that either is very important for entry level starting their career, and maybe why these ones in particular really speak out to you. And maybe Juan, you want to take this one first.
Yeah, there's a couple of things, technologies at the Boeing company that are really important, right? And some of the folks that spoke before from the colleges have mentioned it, right? The 3D printing manufacturing, right? The additive manufacturing, those are things that Boeing commercial airplanes are trying to implement in all the products they build, right? So the more the students coming into an engineering function or manufacturing know about that, the more successful they're going to be, right? The other thing that also started happening is transition of making metal parts getting replaced by composites, right? There's very few engineers that know about composites, and the Boeing company and every company out there, I'm sure, could use a lot more engineers that know about composites and how to analyze them and do the engineering calculations and make sure they're going to work for the product that they're destined.
Definitely. Stacy, I saw you nodding there a little bit. Did are you in alignment with that, or do you have something to add?
I mean, there's a lot of, I think the core technical, and I think when you're in engineering, I think the professors right to focus, like really understanding technical materials and how they can drive and enhance design using 3D printing and, you know, faster manufacturing and making. So one of the things, right, I like to add, a lot of times the capstone projects and different things are, you're coming up with one idea, and so you're learning how to take a customer requirement and really design a product. But a lot of times I think students only get exposure on that one-time prototype, and so really thinking through how to design for manufacturing, how to design for the masses and larger quantities, and really understanding those trade-offs. And I think with that, it's using analytical tools and stack ups. I heard a little bit about that from the college representatives, and understanding how you can see that product through from start to finish, and using statistics to prove safe and effective. And so I think a lot of times, right, engineering doesn't as much focus on the math side and the statistics, and those are additive classes, at least when I was in school as an engineer, that I had to go do as electives. So I think that's all like the base technical skills. Now I will say engineering outside of direct R&D, you know, understanding more about the regulations and the design control process and risk management and how to integrate all that together. And from a system perspective, you know, I think a lot of times our products are getting more and more complex in the market and in the space, and how everything works together. And so that complexity and the smaller parts get smaller and smaller and smaller, or bigger and bigger and bigger. And I think that complexity and just helping students technically work through how to separate and how to put those in pieces and design one well, but then design for the masses. I think there's a lot of technical little things that I think when you're entering the workforce, and I think Juan hit this, right, is it takes a long time to learn some of that base knowledge of how these things fit together. When products aren't designed in a few months, they take years to develop. And the students wanting to kind of push through that really quickly and not focusing on those technical bases to design a product.
Yeah. Oh man, so much that you said there hit home for me. Thanks, Stacy. Sydney, I'd love to get your perspective as someone who's earlier in their career. You know, we've been talking about things and advice for early career. What are some technical skills maybe that you've found most beneficial for you starting out, or things that you wish you had more of?
Yeah, I can definitely hit on that. I think the most useful thing so far has been the CAD modeling. So 3D modeling and drafting, I've already been doing a ton of that, and being able to use the programs as well as read and understand the drawings is really helpful. When you want to communicate with suppliers, you need to know how to do tolerancing and communicating your ideas. And then technical writing, I'm also using a lot. Starting out, I've been doing a lot of test method development. So again, being able to convey your technical ideas in a clear, concise way. I can design an amazing test method, but if I can't show other people how to do it, it's not going to be useful. And then something that I'm definitely wishing I knew more about, and that I'm learning a lot about on the job, is the manufacturing knowledge, which was already kind of touched on, but just thinking about how the manufacturing process will influence your design is something that I don't have a ton of experience in, and I wish I had more. So, and I would say, like, if you're hearing this and panicking that you don't know how to use CAD or you don't know that, you can definitely learn it on the job. And I know engineers who do, but it's definitely helpful to be at least a little bit familiar with it. So, yeah.
Yeah, definitely. Oh, thanks, Sydney. All right. Okay. So moving along here again. Okay. We got our first question in the chat. Cheers to Lisa. Hi, Lisa. So Lisa has a question for our panelists. at the high school level, what is the one CAD software we should be teaching our students? For example, how do you feel about Autodesk Inventor versus SolidWorks versus Fusion? And I know there's a number of others. And I don't know if we want to kind of start backwards, Sydney, if you have any advice around that.
Yeah, I definitely have a limited view, but what I'm using here at Medtronic is SolidWorks. That's my personal favorite program. But I also used Creo when I previously worked at Abbott. So those would be the two I know some companies are using.
SolidWorks is what we use as well as like our main design platform. I think the going more the 3D route versus the 2D in today's world and being data-centric programming and everything, the 3D modeling is more important than just a 2D kind of AutoCAD approach.
Awesome. And Juan, is it similar at Boeing, or do you find that you use a different program?
I know that we have 3D models, but I'm not sure which software they use. I know that we do data sets, and those data sets get sent directly to manufacturers, and then they get all the information they need to make the parts from that data set. You know, in the old days, you used to have a drawing and a parts list, you know, on paper and so forth and so on. Nowadays, all of that is electronic, so it makes the design of the drawing and the manufacturing a lot more expeditious to get all the data to make the product.
Yeah, what I'll add, I see the question kind of in the chat, but what I'd add is I think, yeah, it's more important like the 3D modeling over 2D because of where we're going from a industry perspective is everything's online. We communicate and we save files through the 3D. It's not just the 2D prints anymore, which are important, but the 3D modeling for building, you know, manufacturable molds becomes even more important. I do think, you know, if you learn Creo, if you learn SolidWorks, it's not as much, every industry or every company really has the one that they typically use as a focus. But I think as you learn, if you learn one in high school level, the ability to pick up a second one is pretty quickly. So I would say, yeah, SolidWorks is a pretty simpler one to learn than some of the other ones. I think it's a widely used one across the industry. But there's other ones that you could learn and use, and it's helpful.
Yeah, I would definitely agree with you there, Stacy. I think the fundamentals of how you construct a 3D model, it's like using Google Docs versus Microsoft Word, right? It's the same kind of fundamentals. It's just finding the right button, right? So I'd agree with that. I think, you know, as long as you get one and get that experience, it really helps. It seems like SolidWorks. I do know from my experience with other engineers in the Society of Women Engineers, there is diversity depending on the industry. And I know, again, I think it makes a lot of sense that for certain industries, it is going to be more 3D. Some doing like more things in like pipe or, oh gosh, this is not my forte, you can tell, like heat exchanger design and things that are happening in oil, they still use a lot of 2D CAD just because what they're making is more simple in that regard, but they can model it just fine in CAD, and a lot of their previous drawings have all been done previously in those same Autodesk type systems, so they've just kept with it. So I do think there's some diversity there as well, but echoing what Stacy said, I think that exposure is paramount. All right. Oh man, you guys are lighting up the chat. This is great. Okay. So this is a good one to kind of close out our discussion maybe on CAD, and that is, do any of your companies require an entry-level engineering technician to have a SolidWorks certification? Or is that something that would be a bonus?
So for our technicians, we have technicians that actually build catheters. So they're not on a computer, they're not building the models themselves. They're actually physically using their hands, and they're working with our engineers to build the physical prototypes. So those ones would not require any SolidWorks certification. We do have, you know, a handful of people specifically focused on doing CAD modeling and CAD drawings. And so those certificates and things would be, critical to help them be successful. But then we have, our base engineers, a lot of them do their own modeling as well. So, but that's not necessarily set as a requirement for our jobs. I think it's a huge benefit to have something like that in that experience. As I think Sydney mentioned, being early in her career and coming in and having it.
Anything Juan or Sydney you'd want to add to that?
Well, I'll just add this. I don't think it's a requirement for engineering people coming into the company to have that skill. However, if they do have it, they'll move faster. Most likely, they're going to get, if their job involves making models and data sets, they'll probably get some training. And there may be unique things to the company that they didn't learn in college or high school, right? So most likely they're going to get trained to perform their duties with whatever computer program we have, right? I got trained like 30 years ago to use computer. I forgot what it's called. Anyway, I used to do CADs and they don't use it anymore. 5 years later, they came up with a new system, and most likely in 2 or 3 years, the same thing is going to happen. Something new, better is going to come. So engineers just need to keep learning new things.
Definitely, yeah. And I feel like even when it's just the new version of SolidWorks, I'm already trying to find the buttons all over again.
I think it used to be called computer vision or something like that.
Yeah.
Anyway, a long time ago.
That's a really good point, though, Juan, about companies helping with that development or around that teaching. And that kind of leads into Angela's question here in the chat. And he's saying that OCC has educational programming in engineering and technology. And the question for our panelists is, would you consider having your engineers and technologists teach or team teach courses on their site to train students on industry needed skills, such as composites, like you mentioned, Juan? Would that pique anyone, not to put all of you on the spot here, but is that something you'd be open to or consider?
Well, I think it's a good idea, but the Boeing company is so big, I don't know where we would start to make that program work, right? We have people in Seattle, people in just about every city in the United States, right? So that has to be championed by somebody really high in the Boeing company. So.
Yeah, so like what I've learned, especially about partnering with universities, because I lead a Women in STEM initiative here for youth and university, which is how I kind of got connected into VitalLink. But I would say is what I've learned is finding the right person that has a passion. And so, as I'm getting more and more connections with different people and I hear, interest internally, the more specific around like different opportunities and different needs, I think there's always an interest. And I know people currently that go and even one time teach a course or share a little bit more. So I think there's always those unique opportunities that are happening. I say in J&J, it's just like Juan says, right? There's not necessarily a formal way to go do it. It's typically people connect with the next generation and impacting because they're passionate about it and they see the need and they have a desire to teach. And so it's just finding and making those right connections. And I think, VitalLink has done a great job really starting to connect high school professors to colleges to industry. And I think the more these types of connections happen, I think then naturally some of those other connections can happen to really then influence the longer term impact.
Definitely. Yeah, that's so true. I feel like that's been my experience with VitalLink as well. You plug in somewhere and create that network of passionate people to help with that. That's awesome. All right. And anything else to add on that one? Otherwise, I'm going to move on to our next question. I guess I should add, so for Medtronic too, regarding those types of things, I think it's similar to what Stacy said for us as well. That's been my experience. I somehow hosted a student tour on site at Medtronic, and now in the last few months, I've done 4 or 5. So I think once you make that connection, then it can really expand, and you find the right people to make those links to be able to offer those types of things. I think that would be great. All right, just check the chat here real quick. Okay.
I would like to just generally add, and this isn't a question that's been asked or something. I do, so it's interesting, and Morgan, you might be able to relate to this, but as high school students and college professors, as students are kind of looking at different roles in industries, I know specifically in medical device and med tech, there's a expectation that people seem like they need to go into biomedical engineering to be successful in the medical device kind of industry in the field. And something I just want to have you guys maybe help with around the communications, right, is it's strongly important to get strong mechanical engineers, electrical engineers, system engineers. It's to be able to come in, we're developing very technical products that interface and work together as systems. And I think sometimes an electrical engineer doesn't naturally think, oh, I'm going to go work in medical device industry. And typically the biomedical engineers are the ones that are saying, I want to go work in the medical device industry. But then the biomedical programs can lack sometimes the technical depth that's needed from material expertise and the electrical, how you set up circuits and boards and how you design software differently. And so that's just one of my things that I always hear, and I want to share that perspective, that as you're guiding students and as they're thinking, hey, I want to go medical device route, or I want to go work on cars or airplanes, it's not as always about, there's sometimes these specialized degrees, but they still need the fundamental mechanical, electrical types of skills to be successful in medical industry.
Yeah, Stacey, I think it touches on what you said earlier around how complex things are becoming, right? It's so interdisciplinary. And Juan, what you mentioned about being on teams, right? It's making sure that team, not everyone's going to be good at everything. It's the diversity of that knowledge, and that each person brings that depth that really makes it function well. And to have that interdisciplinary aspect of it, I think is really important.
Another thing I wanted to mention that it's really important for us at Boeing is to have engineers that have knowledge about materials and processes, right? A lot of the times you're building a product and there's so many materials that you can choose from that have different properties for aircraft or for spacecraft, and they have to have special properties or special welding or titanium to stainless steel. And there's very complex processes to do that. And I don't know if those things get taught in college. Well, I know there's a materials and process class in college, but I don't know that they go very deep. I don't know if they teach in high school those things, but that's an area that the Boeing company is always looking for material and process engineers, because we don't have enough of them. There's too many things, welding, all kinds of things material engineers do that there's always a shortage.
Yeah, high demand there. Yeah, for sure. And especially as new materials come out, right? Like the composites, or I know for us, it's polymers, right? There's so much there to learn, that we're constantly learning ourselves as well. All right. So those are some great questions in the chat. So please keep having them come in. I'm going to transition back to some of our other ones that we have prepared, but we'll jump back as you have them. So the next question I want to ask is, let's see, I'm looking at these now. I want to see which ones. We only have so much time. I want to make sure we cover it. I think this is an important one, and I want to kind of get your guys' perspective on it. Considering entry-level applicants, right? So people for first job maybe, how do you weigh their work experience versus completed degrees? And I'm curious, and because we talked about certifications and stuff earlier in the college panel, how do those kind of balance out? How do you consider that when you're interviewing or hiring a new engineer or a new technician? I don't know, Stacy, if you'd like to take it first.
Sure, I can start. So I would say, so I always separate technicians and engineers because for us, they're very different roles. Technicians is all about being hands-on, and, even in our interview process, I think we do a lot of more hands-on activities for that. From an engineering perspective, and I like to say, right, experience, the education is giving you the solid technical foundation, which is why even with, mechanical engineers, electrical, materials, biomedical, it's really getting into that technical academic level. But then I think there's the application level. And I know a lot of times right in high school and and earlier in your university, students are trying to find ways to get experiences. And as Juan and I both, right, and we both mentioned that our typical internships are more juniors and seniors, later in college. But I think students in high school, as well as in earlier in their engineering degrees in their programs, the more that they can get experience, even working with other students and mentoring, or working on, we like to say, like, if you get hands-on working on a car or doing something else that maybe not be directly in the field, but you can develop individual skill sets that you can then translate into that work environment, just like leadership and teamwork and communications, like getting involved in nonprofits or volunteering. And as I always say, pick one or two things, get active, develop a skill set that then you can take and translate. And so if you can't get that first job because you don't have an experience, you can use these other experiences to help translate that into a full-time role. And I think that's where students sometimes they don't know how to make that connection between those two.
Yeah, to be able to convey why that experience lends itself to that job. Yeah, for sure. It makes you stand apart as an applicant when you can do that, for sure. I'm curious, Sydney, in like your interviewing process and applying, and I'm sure doing a lot of that most recently, what do you think about your experience or about your degree or classes helped you stand apart as an applicant?
I think, and if you have something on your resume that is not just classes or even beyond, like an internship, like something you did as maybe a personal project, or like my school had a 48-hour design challenge over the weekend, I think doing something like that to prove that you actually are passionate about this field can definitely help, because everyone takes the same classes. So everyone graduates from your university is going to have pretty much the same skills, but getting those experiences to show you're passionate, and just, any kind of internship experience is so much more valuable, at least from what I've seen. Like, I think I started getting attention from employers after I actually had like a 6-month internship where I was getting hands-on skills and was telling them about that, not just like my favorite class I had taken. But obviously the education is important as well to get the skills that you need for the job. So, yeah.
Yeah, definitely. Thanks, Sydney. Juan, did you want to add to that as well?
Yeah, I'll concentrate more on the engineering side. I'm sure for technicians, if they get a certificate or they go through a apprenticeship program, that will give them the experience they need to start working at a company at that skill level, right? But for engineers, the most important thing is to get that degree, get that paper that says I have a bachelor's in science in aeronautical engineering or mechanical or electrical or computer science. That's your ticket for a job. That's the most important thing. Now, if you have a company that offers co-op programs like they used to a long time ago, I don't know if they still do. Now we do internships. When I was in college, I was fortunate enough to be in a co-op program with Ford Aerospace in Newport Beach, California. And that guided me to become a mechanical engineer, 3 years or 2 years before I got all my degrees, right? And so that is a good thing if companies nowadays could offer that. But degree is the most important thing. The next thing is if you can get an internship for a year or two before working for a large company, that will give you some skills, and then you can put that in your resume, and it'll make you more appealing to your new employer.
So Juan, I would love to piggyback on your whole co-op versus internship, and with a lot of college professors and leaders on here, you know, I was able in my career actually to do a co-op as well, and not just an internship. You know, it took me longer to graduate because I spent more time working, but I got more value out of my classes. I've talked to different professors or different people throughout California, and I think I'm not from California, didn't go to school in California, but I think, you know, if there is a way to get back to being able to work with a university is to have a co-op program where they take a semester off, but they're still a full-time student, and being able to get that work experience, it actually opens the door for more opportunities. It is hard to be able to bring a student in, get them trained, get them up to speed, and have them be successful in a 12-week internship. But if you can get you know, turn that 3 months into 6 months, it makes a huge difference to be able, and the number of students that you're able to bring through also can make a difference in that. So if there is any of the universities on here that have that option or anything, I'd be interested to connect with you offline and learn more about it from an engineering perspective, because I do think it's something that we've looked for, but I haven't really seen it here locally in California. So we've done a lot of our internships and people stay on part-time sometimes, but that could be a major direction change from a university connection to a business potentially.
Yeah, definitely. Oh, sorry, Sydney, go ahead there.
Yeah, I was just gonna say quickly, just to emphasize that even more, like when I said before that experience is what I think made employers actually take me seriously, is I had a 6-month co-op, and then, you know, everyone I talked to at the career fair, I started being one interview for the 8 people I talked to like 8 interviews for the 8 people I talked to. So just a personal example of how that really helped me.
All right, so co-ops, the future. That's awesome. All right.
It's part
so
of the past too. We need to reinstate it.
There we go. Before we close out, because we're running out of time, is there any last advice anyone wants to give to our attendees today, to any of our high school educators that are watching this panel?
So I'll give one. So I think especially high school professors and college, you know, I think one of the things I like to say is it's from, if any student is considering to go into engineering, I would encourage them to at least pursue it and start in it. It's easier to change out of engineering into another science or into a business. It is very difficult once you start to then convert from, say, business into engineering or some other way. So I really do, and I was like that, you know, if they're even considering it, they're good at math and science, it would never hurt them to start that way in that pursuit, and being able to see if it's the right fit. And, you know, we have a lot of people in engineering degrees doing clinical work in the field and doing marketing roles and all these other things. So I do think that people associate engineers with the R&D engineer who comes up with the next big thing, and that's what engineers do. And, you know, engineering roles, they go so much farther beyond that I think a lot of times students can have a limited mindset of what an engineer does in the real world and what all the different opportunities and roles might be.
Definitely. Juan?
I have something else that I want to add. Some of the teachers mentioned the importance of taking advanced classes in high school, right? So I had the privilege of mentoring an engineering student at Valley High through the High School Inc. Academy program, right? And he took advanced physics, advanced chemistry, advanced calculus, you know. And practically when you do that in high school, I know it's hard, but that almost shaves off about a year of your college career. And if for the kids that can do that, more power to them, right? But courses in physics, chemistry, calculus are really important for all those kids that want to pursue a career in engineering. And the earlier they do it, the better. It's almost guaranteed to give them, 15 to 20, 30 units towards their degree. And they'll be miles ahead when they get to college.
Well, and Juan, that might be the gap that they can then use that 1 year extra in college and still complete in 4 years to actually get their engineering degree, but get the experience at the same time.
Absolutely. And for me, it only took me like an extra semester. Even though I worked as a co-op student, I was still able to finish just one semester late.
Yep.
It's always, it's worth it. It's really worth it.
Definitely. Well, thank you all so much. This has been a great conversation. I'm glad we were able to share, and thank you all too, and the engagement in the chat and your questions as well. And I just want to thank you for the opportunity to moderate this panel. And I'd like to hand it back now over to Ari.
Yes, thank you so much, Morgan and the industry professionals. We're so excited to hear from you all. There's been a few teachers that have already emailed me wanting to know how can they talk to you all personally. So teachers, again, if you do have any questions about a tour or wanting to know how you can get your students signed up, email me directly. Ashley, if you can please type my email into the chat for them. Ashley's also going to share in the chat our evaluation, which will take 2 to 5 minutes. We enjoy your feedback, and we truly want to make sure that we're on the right track to give you all the information you need for your students. And also, please keep in mind, again, Manufacturing Month is coming up, the month of October. Our first tour is actually with Miss Stacy Darling at Johnson & Johnson. I was told the students are going to learn so much and create so many things. So be sure to check out our website or follow us on social media to make sure that you stay in touch with everything that we have going on with your students. And if you are interested in having any programs or have some ideas and want your students to go on any tours, participate in any pathways or workshops, you can go directly to our website at vitalink.org. Go to the programs tab and you'll see a full length of information, programs that we have. If you don't see anything you want, we can create it for you. It's that simple. Thank you all so much for joining us, and we hope to see you next time and in Manufacturing Month. Thank you. Have a great weekend.